Hello and good evening. I thought I'd do a quick video from outside where I live in my garden. It's around 9 p.m. at night. It's a beautiful sky out there. There's the moon, and there is a street lamp, and the bright thing to the right of the street lamp is the star Sirius. And so I'm right now filming Sirius. That's the bright thing on the screen here, and there's a couple other stars right here. And what this telescope is doing is it's tracking with a single motor. The telescope is perfectly tracking that star. And just to show you how precise that is, so the telescope is currently connected to this computer, and when I look at the sky here, we can see Sirius. The bright thing up there is the moon. And just to give you an idea what the section or the screen that I just showed you that the camera on the telescope is currently filming, just to show you how big that is, we will zoom in on Sirius right here. And you see this little red rectangle right here? That's a projection of the screen of the CCD chip, rather, of the camera that's currently mounted to the telescope. So this is what the camera is currently seeing. Those are the little stars that I just showed you. The image is a little flipped because the camera is inverted. So this is the portion of the whole sky that this telescope is seeing right now. This is a tiny, tiny, tiny section of the whole sky. And so a thing that flat earthers continuously ignore is the fact that we can track that movement to that precision with a not really expensive kit right here. This is off-the-shelf stuff that everybody can get, the software as well. And so I can track this star and anything else, mind you, the sun, the stars, the moon, with that mount. And this mount is right now just moving one axis. I've set up a second camera right here. That's this guy here. This is a regular cheap-ass tripod for cameras. And what this is doing, this is also filming the sky. So you can see this camera is taking 4-second exposures, and it's automatically stacking those 4-second exposures. And you can see the houses in the back, they obviously aren't moving, so those images are just stacked on top of each other. That doesn't change, but what we see are those streaks up there. Those are the stars moving. And as we continue throughout the night, those stars will continue to make streaks. We should also see that mount moving. And so this will prove to idiots like Gary Wybenga that the mount is moving with the stars perfectly, no matter where I point the mount to. I can point this to Sirius, I can point this to Polaris, I can point this anywhere I please, and the mount tracks the star perfectly. Another funny thing that flat earthers don't get is that there are many different constellations in the sky. This is in the northern hemisphere. This is also known as a winter constellation because you can only see this in the wintertime. This constellation will move over the months. So now we have February, it's 9 p.m. Orion is high in the sky, and around March, April, this constellation will continue to move to the right. And at some point in, I don't know, April, April, May, at the latest, I think, this constellation will set when it's dark. It will not be visible anymore. And we will see the summer constellations, like Cygnus, for example, and Lyra, and other good stuff. So the point of this is that we cannot see all the constellations throughout the year. They move with the movement of the Earth around the Sun. We do not see this movement in a single night, because 1 year is 365 days. But when we look at the sky multiple nights throughout multiple months, we can see the constellations shift and move and also set. Other constellations don't set in the northern hemisphere. For example, if I can get this to work, if we look at other parts of the sky, for example, around Polaris, there's the Big Dipper or Big Bear, and other constellations that are visible throughout the whole year because they are directly above us. This is not just a flat earther debunking video again. So Gary, do not even think that I make videos exclusively for you or any other flat earther. You guys are not important, not at all. So to get to the point, tonight I'm filming Sirius, as I said. I'm recording the frames, I'm saving them, and hopefully, weather permitting, I will look at Sirius again in about 6 months. Because in 6 months, Sirius will rise again in the morning sky. So right now, it's rising at around, I don't know, 5 or 6 in the PM. It's visible around through the whole night. And then, as I said, in the summertime, it will slowly disappear from the night sky, and it would be visible throughout the day if the sun wasn't up. And so in fall, and again in 6 months' time, Sirius will be visible very early in the morning before sunrise. And I will take pictures around that time when Sirius rises again. So I hope to see that Sirius will have been shifted relative to those other stars right there, because Sirius is the closest star to us that we can see in the northern hemisphere. I don't know if this works. I don't know if my equipment is precise enough, but I will give it a shot. Indeed, the stars do move when the Earth rotates around the sun for 6 months. The stars, in fact, do move, but they move at a ridiculously small amount. I think the predicted movement for Sirius via parallax is around 0.3 or 0.4 arc seconds. So it's really tiny movement. But I will give it a shot, again, as I said. So this is the first part of my parallax experiment, and I hope to show you the second part in around half a year. So long guys, have amazed, and I'll see you soon. Take care.